All right, we're moving on to Chapter 2, Section 5, solving equations involving absolute value. We've talked about absolute value a little bit in the past, correct?
Yes, sir.
Does anyone remember what absolute value means?
It means digits away from zero.
Yeah, distance from zero. It's how far a number is from zero. Or just distance in general. And we'll see a little bit more about that here in just a second. So our equations are going to be involving absolute values today. Absolute value equations contain at least one absolute value expression. The simplest form of an absolute value equation is the absolute value of x equals n. Since absolute value represents distance, you must consider the case where the solution is x units from zero in the negative direction on a number line, and the case where the solution is x units from zero in the positive direction. So here's what I mean when we say that. We got a number line, right? Distance is not negative, correct?
Right.
So whenever I'm seeing how far a number is from zero, there's distance this way in the negative direction on the number line, as well as this way in the positive direction on the number line, right? Because I can go that way a certain distance, and I can go that way a certain distance. Can I go that way 5 units?
Yeah.
Yeah? Can I go that way 5 units?
Yeah.
Yeah. So when I'm solving my absolute value equations, I've got to account for both directions when I'm dealing with that distance. Does that make sense?
Yes, sir.
Okay. When solving equations that involve absolute values, there are 2 cases to consider. The expression inside the absolute value symbol is positive or 0. That's case 1. And then case 2, the expression inside the absolute value symbol is negative. So here it is explained with symbols and an example. For any real numbers a and b, if the absolute value of a equals b and b is greater than or equal to 0, that's a key stipulation right there. Because this is saying my distance equals b, right?
Yes, sir.
So my distance must be either 0 or some positive number. Can distance be negative? No, that's why it has this stipulation of being 0 or any positive number. Okay? So if absolute value of a equals b and b is greater than or equal to 0, then I've got these 2 equations. A equals b or a equals negative b. It's accounting for the distance in the positive direction and accounting for the distance in the negative direction. Does that make sense?
Yes.
Okay, so I'm setting up essentially 2 equations. Okay? You guys okay with that?
Yes, sir.
Okay. So, if I get the absolute value of d equals 3, I'm asking what number is a distance of 3 units away from 0?
D.
Well, I'm trying to figure that out, right? So what number or numbers are 3 units away from 0?
Negative 3.
3 and
Negative.
negative 3. So I've got 2 answers there. 2 numbers are satisfying my equation, right? Negative 3 is a distance of 3 units from 0. Positive 3 is also a distance of 3 units from 0. So I got 2 solutions there. Does that make sense?
Yes, sir.
I'm accounting for the positive direction as well as the negative direction. We good with that?
Yes, sir.
Any questions? Okay. Consider the equation, the absolute value of x equals 3. This means that the 2 points on the number line where the distance between 0 and x is 3. So we're trying to figure out what x is. So the distance between 0 and whatever number this is, we're trying to figure out and see how far, what number is 3 units away from 0. Those numbers are solutions to the equations. Kind of like what we talked about on the previous slide, the distance between 0 and negative 3 is 3. So negative 3 is a solution to my equation. The distance between 0 and 3 is also 3. So 3 is also a solution to my equation. And you can see it on a number line right here. I'm looking from 0, 3 units in the positive direction. That would be the positive 3. I'm looking from 0, 3 units in the negative direction. That's negative 3. So both negative 3 and 3 are solutions to that equation. So if the absolute value of x equals 3, then x equals negative 3 or x equals 3. Thus the solution set is negative 3 and 3. You can graph the solution set by just graphing each solution on the number line. So draw your number line and put a point at negative 3. Draw your number line, put a point at 3. That's you graphing the solution set. For each absolute value equation, you must consider both cases. If you only do one of the cases, you get half the problem correct. You've got to consider both cases every single time. Everyone got me?
Yes, sir.
Everyone say you must consider both cases.
You
Must consider both cases.
Good. I've got to account for the negative direction and the positive direction on the number line. To solve an absolute value equation, first isolate the absolute value on one side of the equal sign if it is not already by itself. So what I mean by that, looking outside of your absolute value bars, I don't want anything being added to it, subtracted from it, multiplied by it, or divided by it. So if I give you absolute value of x minus 3 plus 3 equals 4, right now is the absolute value by itself on one side of the equation.
No.
No, what's with it?
3.
Plus 3, right? We're looking at the absolute value as a whole. I don't want anything going on outside of those bars. So in order to solve this, before I do anything else, I've got to get the absolute value by itself. So I would subtract 3 from both sides there. And that would get it by itself. Does everyone see what I mean by when I say that?
Yes, sir.
So I don't want anything added to it, subtracted from it, multiplied by it on the outside, or divided by it. I want it completely by itself. So first isolate the absolute value on one side of the equal sign if it is not already by itself. I know that's a lot of information that we just covered, but are there any questions about any of that information before we look at some examples? Okay? Okay. Example 1. Solve the absolute value of y plus 2 equals 4. Then graph the solution set. Solve the absolute value of y plus 2 equals 4. Then graph the solution set. So, down here, what does it first tell me to do?
Isolate.
Yeah. Isolate the absolute value on one side of the equal sign if it is not already by itself. So looking at the left side of my equation, because that's where the absolute value is there anything going on outside of my absolute value bars?
No.
No. So would you say it is already isolated or no? Yeah, I'd say the absolute value is already isolated by itself. Are we okay with it?
Yes, sir.
Okay. Now I can go about solving the actual equation. Remember, whenever we're dealing with the absolute value, we've got to account for the positive direction as well as the negative direction. So here's how we do that. I'm going to create two equations. Okay? Two equations. My first equation is going to be the exact same as my original, just without the absolute value bars. So I just rewrite it without the absolute value bars. This is me accounting for the distance in the positive direction, positive 4. We okay with that?
Yes, sir.
My second equation is going to be very, very similar to this. Any ideas what's going to be different? If I've got to account for the negative direction as well?
Y minus.
Close. We do need to change one sign. Yep, negative 4. I've got to account for the distance in the positive direction. That's where that positive 4 comes into play. And account for the distance in the negative direction. That's where that negative 4 comes into play. So, it's going to follow that same process every time. First equation is exactly the same without the bars. Second equation is exactly the same, except I'm making that c value negative. Okay? We okay with that?
Yes, sir.
Now, I'm just solving these two equations for y. So on both of them, how do I get y by itself?
Subtract 2.
Subtract 2.
Subtract 2. First equation, I get y equals, what's 4 minus 2?
2.
2. There's one of my solutions because y is by itself.
6.
Here, negative 4 minus 2 gives me
Negative 6.
negative 6. There's my other solution.
Now which one is it?
Are we okay with that?
Yeah.
It's both of them. Or it should be at least. I can always, how can I check my solution?
Plug it in.
Plug it in. So I got to check two solutions here. So if I plug 2 in up here, what's 2 plus 2? 4. How far is 4 away from 0?
4.
4. Does 4 equal 4?
I hope so.
Yes or no?
Yes.
Yes, it does. Then you can plug negative 6 in. What's negative 6 plus 2? Negative 4. And what's the absolute value of negative 4?
4.
4. Once again, 4 does equal 4. So both solutions check out. Both of these are my solutions. If you only do one of them, you only get half the problem correct. I've got to account for both cases every single time.
Shut.
Okay? What else does it tell me to do?
Then graph the after the solution set.
Graph the solution set. So you guys, we're going to have to draw a number line here.
Eight, 7, 6, 5. Oh,
So I just draw a number line, and I put a point at each number on my number line. So I'm going to put a point at negative 6. And I'm going to put a point at 2. Everyone okay with that graph? So, what this equation is saying, earlier, we wanted to find the number of numbers that were a distance of 3 away from 0. Right? There was nothing going on inside the absolute value. Here we got some stuff going on inside the absolute value. So that changes my position. I'm no longer finding a distance from 0, but I'm finding the distance from the opposite sign of that number inside. So what's the opposite of positive?
Negative.
Negative. So I'm finding the numbers that are a distance of 4 from negative 2. Let's see if we did that. Here's negative 2. How far is 2 away from negative 2? 1, 2, 3, 4. Which is what I wanted, right?
Yes, sir.
How far is negative 6 away from negative 2?
4.
4. So I got both my solutions correct there as well, right? Does everyone see how this equation was being read?
Yeah.
I want to know which numbers are a distance of 4 away from negative 2. Okay? Questions on example 1? We okay? Okay. Example 2. Solve the absolute value of 3x minus 4 equals negative 1. Absolute value of 3x minus 4 equals negative 1. Who can help me out here? What do you guys think I need to do?
Account for both sides.
Okay, so how would you do that?
Positive or negative.
Well, tell me what to write.
3x. Okay, so 3x minus 4 equals negative 1.
Okay?
And then 3x minus 4 equals positive 1.
Okay, does everyone agree with that?
Yes.
I disagree.
Dang it!
It's okay. It's okay. Anyone know why I disagree?
What?
Okay, let's talk about it real quick. At the very beginning, for any real numbers a and b, if absolute value of a equals b, and b is greater than or equal to 0. Is my b value greater than or equal to 0?
No.
No. So, can I set up my two equations? No, because b is not greater than or equal to 0. Any ideas what it is? Nope. This b value is talking about my distance, right? I'm saying I want my absolute value to be a distance of -1. Can distance be negative?
No.
No. No solution.
Oh.
My distance cannot be negative, and that's what this equation is reading. I want my distance to equal -1. Distance can't be negative, so it's no solution. There's no number that I can plug in that would make this equation true. And if you think about it, that makes a lot of sense. Because what happens when I take the absolute value of something? It's always going to give me what type of number? Positive, right? No matter what number I plug in here, it's always going to pop out a positive number after I take the absolute value, right?
Yes, sir.
So will any, or it might pop out 0. Would 0 or any positive number ever equal a -1? No. So it makes sense that it's no solution, right?
Yes, sir.
And my distance can't be negative. So that one's really easy. Those are really nice. Okay? Also, just be careful. Before you do anything, you do have to make sure the absolute value is completely by itself. Is my absolute value isolated by itself? Yeah, there's nothing going on outside of it. Nothing added to it outside, subtracted from it, multiplied by it, or added to it. Okay? So, before I decide it's no solution, I've got to make sure it's by itself, because once I do some adding or subtracting, multiplying or dividing, it might change this to positive to where I can set up my two equations. So always check first before you decide if it's no solution. Okay? Questions on example 2? Can I move on?
Yes, sir.
All right, we're going to work backwards now. It gives us our two solutions, and it wants us to write an equation involving absolute value for the graph. Okay? So, here's what I need to do. I need to find the midpoint of my 2 points. Does anyone know what midpoint means? Yeah, the middle. The number that's the most middle between these two points, 27 and 17. Okay? So I want to find the midpoint between 17 and 27. What is it? 22? Well, let's check. Let's start from 22 and count out to 27. 1, 2, 3, 4, 5. If it's the same going the other way, then yeah, that's my midpoint. 1, 2, 3, 4, 5. Everyone okay with that? Everyone agree that 22 is my midpoint?
Yes, sir.
Any confusion on that? Okay. So, I've got my absolute value. You can choose whichever variable you like if it does not tell you a specific variable. I'm just going to use x every time. Earlier, we were asking ourselves, I want the number that's the distance of 4 from -2. Everyone see how that's a +2? It's always going to be the opposite sign. So, what number is this right here? Positive 22. So what do you think I need to put after x?
Minus.
-22. I need to change its sign. So I'm finding the two numbers outside of positive 22. And how far are these two numbers from 22? How many
5.
units? What?
5.
5 units, right? So that's my distance part of it. So the distance will be on the right side of the equal sign. Everyone okay with that? So I'm looking for the two numbers that are a distance of 5 from positive 22. And there's my equation. We okay with that? So once again, your midpoint is the number that's going in the absolute value with the variable. Change its sign. Okay? Put a variable in front of that sign. The distance part how far these 2 points are from your midpoint. In this case, it's 5. The distance goes on the other side of the equal sign. Think you guys could reproduce that
No. Yeah.
using different numbers?
Sure.
Okay, good. Any questions on example 4? We okay? There's your assignment.
No.
Be on Canvas. 2.5, homework number 1, MH.
All right.
Yeah, do we have any questions about the notes before I end the recording?